First one. Basically, we're just doing the difference between a central angle and an inscribed angle. A central angle is equal to the arc it subtends, and an inscribed angle is half. So our x value is going to equal it. So we'd have x equals 164. I'm sorry, that's a 4. X equals that. And then y is going to equal half that. So y is going to be half, so 164 divided by 2, because it is an inscribed angle. And so we're going to have 82 degrees for those two. Now, for the next one, we're actually going to learn more about this today. But we have to realize that we can't go straight to z today. Z is not an inscribed angle. It is not a central angle. But what we do have is a triangle. Let me point out the triangle I'm looking at. That triangle that has inscribed angles. So I first look at that inscribed angle there. It's pointing to that 64. Half of 64 is 32 degrees. So this is 32 degrees. Well, if we look here, we have another inscribed angle that forms that 86 degree arc. Half of 86 is going to be 43. You don't have to throw your calculator on the ground. And we do have a triangle, so we would just do 180 minus 43 minus 32, which will give us this angle right here is 105. Well, I really just care about the 105 degree angle because z and that angle form a linear pair. They equal 180 degrees. So these two angles together equal 180. So we just have to do 180 minus that 105, and we're going to come up with 75 degrees. Z should equal 75 degrees. I think that's A on the board. Am I correct? Yep, so your correct answer should be A. Any questions about that? Questions going once? Going twice? I think a lot of us took that 86 and divided by 2 because we thought this was like an inscribed angle. It is not. It does not touch the circle. That point would have to touch the circle to be an inscribed angle. All right. Hopefully that's a little clear. I also want you guys to do something really quick in your calculator for me. What's 86 plus 64? What does that equal? 150. What does 150 have to do with 75?
It's half of it.
It's half of it.
Whoa.
And that's going to be one of the topics we're going to discuss today. So we don't have to form that triangle. We're going to find out that if we just take those two arcs, add them, and divide them by 2, we'll actually get that angle. But that's a future problem for us. Let's handle a present problem, and that is questions on the homework. Let me bring up a new slide. There we go. Joaquin. 23. 23 says we have a circle. So let's try to draw a circle as best we can. And it says we're going to draw a triangle ABC in the center of this circle. I'll try to make it as... Oh, that wasn't so bad. That wasn't so bad. Let's call this ABC. ABC. Now, I said we have some important facts to deal with an equilateral triangle. First of all of our sides are congruent. And Joaquin, why that's important to us is that means all of the arcs are also congruent. So all of the arcs are also congruent. So that means all the arcs are actually 120. If I split it into 3 congruent parts of a circle, that means all of these are going to be 120 degrees. So that's going to work for every single equilateral triangle you put in there. And we could also check that because the angles of an equilateral triangle are 60 degrees. If you look at this arc, it subtends. It is an inscribed angle. Double it, and you come up with your 120 on all of them. Now it says we're supposed to put P and Q are midpoints of arc AB or BC and CA. So BC, let's put this in So the arc BC is bisected by a point P. So we have a point P right there. Let's put it on the inside there. All right. So we have point P here. And then it says, where else is it? It's also CA that it bisects it. So that is our Q. Then they ask you what kind of figure is the quadrilateral AQPB. So AQ Ooh, hang on, I messed something up, didn't I? Do I have... Fine. We go here. But we have to prove it's a rectangle. We have to prove it's a rectangle. And the way we're going to prove it's a rectangle is we need to figure out what one of these angles are. So the way we're going to prove this is, let me highlight this in purple. Let's look at this inscribed angle here. That inscribed angle there, make this 60 degrees because it's half. So if this is 60 plus 120, we're going to have 180. Half of 180 is 90. And we can do this purple thing for every one of these inscribed angles, that they all are going to be across from something that equals 180 or our diameter. So every one of these is an inscribed angle where the opposite equals 180, half of it is 90. So all of these are going to be 90, which makes it a rectangle. All right, other questions? Other questions going once? Going twice? Okay, so up until today, we had an inscribed angle and we had central angles. We had nothing that met somewhere within the circle. It had to be either inside, directly inside, or it had to go to the outside of the circle. So just a couple review concepts we have. A tangent line. A tangent line is a line that intersects a circle in one place. So that might look like this. That would be a tangent line. A secant line is a line that intersects a circle in exactly two places. So a secant hits the circle in two places. Now the thing about a secant line is it forms what's called a chord. That chord is something that hits two things of a circle, but is a segment. So here's the difference between a secant line and a chord. The chord has two endpoints. They end on the circle. Secant hits it twice. A chord has two endpoints on that circle. So the only difference between a chord and a secant is a line. A chord is a segment that has obvious length. All right, so we looked at our bell work. Our bell work, let's go back to our bell work really quick, had this angle Z that is not a central angle and is not an inscribed angle. It meets somewhere inside of our circle that's not the center and is not, the endpoint does not land on the circle. So it's going to look like this picture here. So it says if two secants or chords intersect in the interior of a circle, then the measure of the angle formed is half the sum of the measure of the arc intersected by the angle. So it's going to be half the sum That's why in our bell work I had us add up those two arcs, and it came up to 150. 150 divided by 2 is 75. So that leads us to this little equation here. If I want to find the measure of angle x, I'm going to find the arc. I have these out of order. That should not say AB. I need to correct that. That should say arc AD. That needs to be fixed. And arc BC. Because those are the ones that are formed by this x and its vertical angle. If we would do AB and CD, we would have found kind of y. Because we could have found y degrees by doing AB plus DC and having that. So what is down there below is more or less matching our y degree. I also do want to point out that these form vertical angles. So if you find one of these, you found the other one. If you found one of these, plus 180 equals that. So you just find one of them and you have all four of them. Okay, so if two secants or two chords meet up and they form an angle, we just need to add and divide by 2. So for example, this one, what is the value of G? Well, G is definitely not a central angle. It is definitely not an inscribed angle. It's made up of two secants that intersect. So G forms this 74. G forms this 74 here. And G is on the opposite side, which would form that arc over there. So those are the two numbers we need to have. So we're going to go, okay, G is formed by two chords intersecting, or two secants. So we're just going to go 1/2 times 74 plus 32. What's G going to equal then? What does that equal if I do 74 plus 32? We got two people that can do the math? Nice. Yeah. Say that again? 53 degrees? Not a little big. Do I have that right? Yeah. 52 degrees. Whoa, say that again? 53. Okay. For some reason in my head I had 40 degrees, something that threw me off when you said 50, but you are correct. Because 74 plus 32 is going to be 106 divided by 2 is not 40-something, it'd be 53 degrees. Bless you. Now, we could do the same thing even if we have that angle. So it says that that angle that's formed by these two chords is 75 degrees. Well, remember the other one's 75 degrees as well. They are forming the ones I highlighted darkly. So remember, it is angle equals 1/2 arc plus arc. So in this case, we're going to have 75 degrees equals 1/2 arc plus arc. Well, that will be x plus 100. Now, I picked this one for a particular reason. This 1/2 has to be distributed to both those things. But sometimes distributing a 1/2 isn't the easiest way to do it. Joaquin, what might be another way I can multiply by 2? I would probably multiply both sides by 2 to get rid of that 1/2. So that seems like an easier way to go. So we're basically multiplying both sides by 2. That will cancel out the 1/2. Multiply by 2. And we have 150 equals x plus 100. That seems a lot easier because now I'm just subtracting by 100. And we come up with the x equals 50. You might want to just check it in case you made a mistake. 50 plus 100 is 150. Half of 150 is 75. It works out. So x is going to equal 50. So any questions about angles formed by secants or chords intersecting? Okay. Now remember, just learning these is half the battle, because you know once you see the picture with all the different shapes in it, this is something you're going to have to be able to pull out and just know exists. All right, the next thing is going to be what happens if we have angles outside of the circle. So look at those drawings. So we have an angle outside of the circle, but every single line at least touches the circle. This is two secants. This is a secant and a tangent, and these are two tangents. All right, so if two secants, a secant and a tangent, or two tangents intersect the exterior of a circle, then the measure formed is, it's kind of the same. It's 1/2, but it won't be the sum this time. It'll actually be the difference. It's going to be the difference. So the only difference between two secants or something meeting inside the circle and them meeting outside the circle is you're going to add if they're inside, you're going to subtract if it's on the outside. So if we look at this first one, I have two secant lines. Well, they're saying, well, it's 1/2 the measure of angle DE, which I've highlighted here, minus the measure of BC, which is the one here. And that's really the logic of it. We just have to figure out which one's the big one and which one's the small one, because we are subtracting. So the measure of arc DE has to be the big arc. BC has to be the small arc. We don't have to spend a ton of time worrying about that, because if you ever come up with a negative degree using this, it just meant you had the wrong order. It'll be the same degree, you just have to make it positive. So if DE minus BC divided by 1/2 is 50, if you'd flip those two, it would be negative 50. We have to know that we are going to have a positive angle. If it's a secant and a tangent, we need to find the big arc and then the small arc. I guess I could highlight that in purple. This would be the small arc. So it'd be CD, or DC, minus BC divided by 1/2. And finally, if it's two tangents, we find our big arc, which is actually at BDC. And then BC is my small one. We subtract and divide by 2. So doing a couple examples. I don't think I missed anything else up there. Just remember it's big minus small. So in our first example, we have to find x degrees, which is two secants meeting outside of the circle. So x is going to equal 1/2. You need to take your big arc. Your big one's at 86. And we're going to subtract that 32 degrees. Well, 86 minus 32 is 80 minus 30, which is 50. So 54. So we're going to have x equals 1/2 of 54 is going to be 27. Yeah. X is going to equal 27. For our next one, we're going to notice that we know the angle. The arc across from that angle is 76, and the small arc is n. So I'm recognizing, per the drawing, our small one's always going to be the one that's close to the angle, because the further out you go, the bigger the arc is. So the one across is always going to be bigger, so even though I don't know what n is, n has to be the smaller one. So we're going to have 17 equals 1/2. Big arc, which is the one farther away, is 66 or 76 degrees, and then we're going to subtract our n. Now, by all means, you can distribute that 1/2. I like Joaquin's version where we just multiply by 2 just to get that 1/2 out of the way. So I'm going to multiply this side by 2. I'll multiply this side by 2. 2 and 1/2 cancel out and turn to 1. So we're going to have 34 equals 76 minus n. Well, we could either subtract 34 from both sides and then add n, or we could subtract 76 from both sides. Really doesn't matter. What does our n equal? Ellie? 42. Is it 42? Do we agree with 42? We're good with that? Then we'll box it in. If you could do me the kindness, finish the next 2. Finish the next 2. When you have your answers, raise your hand, and I will check you off, saying, yes, you understand this vertex outside of a circle. And then you can start your homework.